Hello everyone, welcome to another video. On this video we are going to discuss the difference between throw and throwx in C#, okay? They might seem the same, but there's actually a subtle difference between them, and the subtle difference is that when you use one of them, throw, you preserve the stack trace. But if you use the other one, throwx, there's a reset of the stack trace. Okay, we will see this in practice soon. But for those of you who are not very familiar with the concept of stack trace, let me first try to explain what a stack is in the context of data structures and algorithms. Okay, so assume that you have a bunch of plates right in the kitchen. So you're washing them, and normally what you do when you end up, washing them is that you place one plate right on top of the other, and then on top of the other, and so on. Okay. So ultimately stacking them up together. And if you want to reach the last plate or the plate after that one, normally what you do is you take the first plate out, right? And then you take another one out until you reach the desired destination, the desired plate in this case, okay? So a stack is a data structure where you put items in a LIFO order, so the last one to get in is the first one to get out. And so this is a data structure that is commonly used in software engineering, and it has a broad scope of usages. Okay, so this is the concept of a stack. Okay, something that you pile up one on top of the other, and then when it's time to remove, you remove from the top, so the last one that gets into the stack is the first one to get out. This is normally called LIFO, or last in, first out. Okay. So in the context of software engineering, you use stacks in multiple occasions, and one of them is the stack trace. So let's say that you're building a program, and that program has a couple of functions. Okay, you have function 1. That function 1 calls function 2, and then function 2 calls function 3. Okay, so function 1 calls function 2, and then in this process function 2 calls function 3. Okay, the stack trace in this case is the list of methods that were executed, okay, until you reach a specific point in time. Okay, so in this case, let's assume that on my main program I call f1. Okay, so that's the method I'm executing. Okay, if you think about the plate analogy, so the first plate that you would have here is f1, okay, because that's the first function that is executed, right? And then while you're executing f1, you call f2. Okay, so f2 is the second plate here. Okay, f2. Okay, maybe I can put this a little bit bigger. Okay, maybe I can add this here. And then when you're processing f2, you call f3. Okay, let me put like this. Okay, so the stack trace in this case is the list of methods that were executed until you reach a specific point in time, or on a specific point in time. So if my point in time is this one, then I would only have f1 and f2. But if I move my point in time here to f3, this is what I observe. Okay, and being a stack, the last one to get into this list of executed items is normally the first one here at the top, and normally the first one to get out once this method is finished executing. Okay. So just to explain to you briefly what this concept of stack trace is. Again, a list of methods that get executed until a given point in time. Okay. Now, this is very useful to have a stack trace, because when something goes wrong, you can actually see the history of methods that were called in. So if I know that an exception occurred, for example, on F3, okay, and after F3, for example, there was an F4, let's assume there was an F4 here, then I know from the stack trace that the problem occurred when I was on F3. Okay, so I have this indication precisely where the problem occurred. Okay, so stack trace is useful in these scenarios as well. Now, since we are speaking about this in the concept or in the realm of .NET, let's maybe check a practical example of this stack trace, okay, in action. So let's replicate the theoretical scenario we just saw. Okay, I will create a function f1. Okay. This f1 function, the only thing it has is a console.writeLine f1, okay, executing f1. Then I would have an f2 here, okay, an f2, and I would have, for example, an f3. And I can have an f4 as well. And we can adjust the writeLine messages here as well, okay. And now I call f2 here, and then f2 calls f3, okay, and then f3 calls f4, okay. Now, if at f4, one of the things I can do is to console writeLine the stack trace. Okay, how can I access stack trace? Well, you have this environment here, this environment object, and you can access this stack trace property. And this will allow you to access the stack trace in any given point in time. Let's invoke here f1, okay. And now let's see this being executed and check the output, okay. So as you can see from the console, we have our console writelines, but then at the end we have the stack trace that is a result of this console writeLine here on line 22. And as I told you before, the stack trace is just a list of methods that were executed into a given point in time. In this case, on line 22, I had already executed the get the stack trace. I already had executed f4, f3, f2, f1, and of course my main. Okay, so it allows you to see the list of methods that were executed up until this point. Okay. Now that we have a brief introduction on what stack traces are, now let's check some practical example here. Okay, when the point is to compare throw versus throw X. Okay, so one thing that I will do here is I will comment this line out, and I will throw an exception here. Okay, just so that this exception gets caught, and I will only get this exception here on the first one here. Okay, catch. Okay, now let me get this. Okay, so now if we run this, what are we expecting? Well, we are expecting an exception to be thrown here and then to be caught here, and therefore this is executed. Okay, let me put a breakpoint in here. Okay, so now let's execute this. And so far we've seen that I have f1, f2, f3, and 4, so I executed f4, but there was an exception thrown. So what I will do here is now I will step in here, okay, and then you should see this printed out on the console, okay, caught exception in F1. And now when you throw, you now should see the entire stack trace showing up, okay. So if I go to this console, you would see here, of course, this my exception here, and because I don't have anything higher up here that handles this exception, but you saw here that I just did a throw, and the throw will actually preserve the entire stack trace, okay. So you will see here that you've executed line 34, that's the first one, then it's the start of your main, then you execute F1, then you execute F2, F3, and F4. Okay, so you see the entire stack trace here of methods that were executed in the meanwhile. Okay, so this is super useful to have this behavior whenever you have issues in production, because you can clearly see and pinpoint the list of methods that were covered and that led to that point in time where an exception was thrown. Okay, so the usage of throw here, okay, normally you use throw inside a catch clause. Throw will preserve the entire stack trace, so you will be able to see all of the method calls that happened until that point in time where an exception was thrown, okay? Now, if I do a subtle change, so keep in mind that I have everything here on the right hand side. I have all the methods F1, F2, F3, and F4. If I just do a simple change, and instead of throw, I just put throw X, and you will actually see here on Visual Studio that it gives you a squiggly line, so maybe indicated that something is not correct, okay? And if I run now this program, what would be the difference here, okay? Now we know that this exception has been thrown, and you will see here that I still have my logging message, I still have this caught exception F1, but, and this is important, it will cut the entire stack trace up until the point where throw X was executed, okay, was thrown. In this case, what happened was I called my main method, and then my main method called F1, and then F1 had an exception, and then throw X will just, cut the entire stack trace, okay? If by some reason I did this and then did the exact same thing here, okay, let me do this, okay. If I did the exact same thing here, you would see here on the throw X, you would see that the stack trace would now also include F2, but it will not include F3 nor F4. So in this case, the method execution goes until F4, but it's not shown because when you use throw X, there's a reset on the stack trace. So if you will, there will be a new stack trace starting on the main program until this point in time. Okay. Now, if we run this just to make sure that we are checking everything correctly, you can see here that I now have this caught exception in F2, and I think now let me ignore this, okay, so that I can actually see this happening, okay. So if I continue, now what will you observe, okay? What you will observe is that now it ends at F2, okay, whereas before it ended at F1 when I had this throw X here, okay. So That's the I would say the main difference between throw and throw X. Okay. Um, Again, throw. If you just do throw will. So if I remove this, throw will actually preserve the stack trace, which means that all the methods that were executed in the meanwhile, their stack trace is kept. Okay, the fact that they were executed, this is kept. But in the other hand, if you use throw X, you will run into the issue that the stack trace is reset. Okay, this means that you lose all the information of whatever was executed before. Okay, now normally I would advise you to always go with throw, because when you're debugging something in production or whatever, you get the exact trace, the list of methods that were executed, and this can help you on the debug. I would only use throw if, as an example, I'm building my own library and I don't want to have default exceptions being thrown or whatever. I just reset the stack trace, and that's all I do. Okay, so if you use my library, the stack trace will start at the library level. Okay, this can be an occasion when you use throw X. I've rarely used throw X. Mostly we use throw for the reason that we have the history of the stack trace. But just letting this out here, because it might be useful one day to use throw X. Okay. So that's it for this video. Hopefully you've enjoyed it, and I hope to see you on the next video. Thank you so much. Bye.